Imagine this. You wake up tomorrow, scroll through the news, and the headline reads, "Breaking. Every planet in our solar system is now the same size as Earth." Wait, what? Jupiter, the monster gas giant, shrinks down like it's been on a crash diet. Mercury, the tiny speedster, suddenly bulks up like it's been hitting the gym every day for 1,000 years. Even Pluto, yes, Pluto gets an upgrade too, now matches Earth in size. Sounds like science fiction, right? But let's play with this. What if? What if every single planet, from the blazing hot Mercury to the icy edges of Neptune, were all identical in size? At first, it sounds kind of fun. We'd have 8, or 9 if you're still rooting for Pluto, Earth-sized neighbors. That means more worlds that might look like ours. Maybe even more worlds we could colonize. Imagine hopping on a spaceship and visiting new Earth just one planet over. Pretty exciting, right? But hold on. Size isn't just about looks. Planetary size determines gravity, atmosphere, and even how the planets interact with each other in orbit. If you start messing with the sizes, you're also messing with the invisible balance that has kept our solar system stable for billions of years. Change that balance, and suddenly the whole place turns into a cosmic demolition derby. Here's the thing. Our solar system is a little like a carefully arranged orchestra. Each planet has its role. Jupiter is the booming, drum-keeping rhythm. Saturn is the elegant violin with its delicate rings. Tiny Mercury is like the triangle, easy to miss but still important. Change the size of every instrument to match the drum or the violin, and the music doesn't just sound different. It might collapse into total noise. So what exactly happens when we force equality on the planets? Does Jupiter still protect us from dangerous asteroids? Does Mars finally get the chance to become a second Earth? Do the orbits hold together, or do they fly apart? Let's start with the giants. These planets are the skyscrapers of our solar system. Jupiter is so huge you could stuff about 1,300 Earths inside it, while Saturn, Uranus, and Neptune are not far behind. But in this scenario, we hit the reset button. Suddenly, every single one of them shrinks down to Earth's size. Jupiter's superpower right now is its massive gravity. It's like the solar system's bouncer, standing at the door and saying, "Nope, you're not hitting Earth tonight," to thousands of asteroids and comets. Without Jupiter's bulk, that protection disappears. Instead of being our guardian, Jupiter would become, well, just another Earth-sized rock. That means the asteroid belt between Mars and Jupiter, currently kept in check by Jupiter's gravity, would turn into a chaotic shooting gallery. Earth might find itself dodging way more space rocks. Imagine meteor showers on steroids, only less pretty night sky and more, giant crater incoming. Then there's Saturn, the show-off of the solar system, strutting around with its dazzling rings. But here's the catch. Those rings exist because Saturn's gravity is strong enough to hold them in place. Shrink Saturn down to Earth size, and poof, the rings scatter like confetti at a wedding. No more dazzling hoops, just sad space dust drifting off into the void. Without its gravity pulling everything tight, Saturn also loses many of its moons. Right now, it has over 80 of them, including Titan, a moon bigger than Mercury. Earth-sized Saturn just can't keep that entourage anymore. Moons go flying off, and Titan might even wander away, becoming a rogue world. And then there's Uranus and Neptune, the frozen cousins hanging out at the edge of the solar system. These two aren't as massive as Jupiter or Saturn, but they're still giants compared to Earth. Shrink them down, and they lose their icy atmospheres and cloudy blue looks. Instead of being majestic balls of frozen gas, they'd probably end up looking like dull, rocky exoplanets. Neptune is famous for having supersonic winds, the fastest in the solar system, but with Earth-level gravity and size. Those wild storms would calm down. No more extreme alien hurricanes, just a boring, slightly windy planet. By shrinking the giants, we remove the anchors of the solar system. Jupiter's gravity shapes orbits. Saturn's mass balances the outer solar system. Take that away, and the rest of the planets start wobbling like a stack of books without bookends. Earth, Mars, and Venus suddenly lose their protective big brothers. It's like turning off the solar system's seatbelt. Now, let's swing the spotlight to the underdogs, the runts of the solar system. Normally, these planets are tiny compared to Earth. Mercury is barely bigger than our moon. Mars is half Earth's size. And poor Pluto, way out in the cold, is like a pebble compared to Jupiter. But not anymore. In our scenario, every one of them suddenly bulks up to Earth size. Take Mercury. Right now, it's too small to hold a thick atmosphere. Its weak gravity can't stop gas from escaping, so the sun basically blows away anything Mercury tries to keep. But with Earth's size and gravity, boom, Mercury suddenly holds on to a proper atmosphere. That means the planet closest to the sun could now have clouds, weather, maybe even habitable conditions, though it'd still be scorching hot. Think Death Valley in July, but worse. Still, Earth-sized Mercury might actually become a candidate for colonization. Then there's Mars, humanity's favorite future vacation home. Normally, Mars is too small to keep its atmosphere thick. It lost most of it billions of years ago, leaving behind a cold desert. But now, Earth-sized Mars would have the gravity to hang on to air and water. It might even rebuild an atmosphere thick enough for liquid oceans. Mars would no longer just be the red desert. It might turn blue again, with lakes, rivers, and weather. If you've ever fantasized about Mars colonization in this version of the solar system, it wouldn't just be possible, it might be better than Earth in some ways. And finally, Pluto. Right now, it's so small that it can't clear its orbit, which is why astronomers stripped it of real planet status. But Earth-sized Pluto? Oh, you'd better believe it would be back on the roster. With Earth's mass, Pluto would clear its orbit, become a full planet again, and probably grow a thick atmosphere. Instead of an icy wasteland, we'd see a frozen world with mountains, glaciers, maybe even seas of liquid nitrogen. In fact, it might look more like Neptune's moon Triton than the tiny snowball we know today. With Mercury, Mars, and Pluto all upgraded, suddenly we've got multiple Earth-like candidates. Colonization would be way easier. Humanity could spread across the solar system like never before. It sounds like paradise. But here's the catch. More Earth-sized planets in close orbits also means more gravitational tug-of-war. Mars and Earth, being neighbors, would constantly yank at each other's orbits. Same with Mercury pulling Venus. The solar system wouldn't just get crowded, it would get unstable. The reason our solar system works is because the planets are all different sizes. Jupiter's massive gravity acts like a cosmic anchor, holding the outer planets steady. The smaller planets, like Mercury and Mars, don't throw much weight around, so they politely stay in line. But when every planet is suddenly Earth-sized, that balance is gone. Imagine 8 heavyweights all trying to sit on the same side of a seesaw. It tips, it wobbles, and eventually somebody gets launched into the air. Earth, Venus, and Mars would be the first to feel it. Right now, they orbit at safe distances, but equal-sized neighbors would pull at each other constantly, nudging orbits closer and closer together. Even small changes can add up. In millions of years, or maybe just thousands, their orbits could cross. And when orbits cross, collisions aren't far behind. Without giant Jupiter, Earth loses its cosmic bodyguard. The asteroid belt becomes a wild zone with rocks no longer held in check. Some slam into Earth, Venus, or Mars. Others get slingshotted into the inner solar system. Picture Earth pelted by space rocks like a cosmic dodgeball game. Meanwhile, the outer solar system loses its structure. Neptune and Uranus aren't heavy enough anymore to shepherd icy objects at the edge. Comets could come flying inward with no warning. And don't forget about moons. Right now, planets like Jupiter and Saturn hold dozens of them in place. Earth has just one, and it's perfectly balanced to give us tides and stable seasons. But Earth-sized Jupiter and Saturn wouldn't be able to hang on to their moons. Dozens of them would be flung into space like marbles knocked out of a ring. Some moons might drift into new orbits around the sun. Others could smash into planets. And if we're really unlucky, one might get pulled toward Earth. Imagine a moon the size of Ganymede, bigger than Mercury, crashing into us. That's game over. Pretty soon, the solar system looks less like a graceful dance and more like bumper cars at an amusement park. Planets tug, asteroids fly, moons wander, and the once stable orbits spiral out of control. And here's the terrifying part. Earth might not survive. If Mars or Venus shifts too close, their gravity could either fling Earth out into the frozen darkness of space, or drag it into a deadly collision. So here we are. We started with the fun idea of every planet being the same size. At first it sounded exciting. Mercury with an atmosphere, Mars turning into a second Earth, Pluto strutting back into planet status. But as we dug deeper, things started to unravel. And now comes the big reveal. The solar system simply wouldn't survive. When all planets are Earth-sized, their gravity pulls on each other far more strongly than it does today. Orbits don't stay neat and circular. They drift, they wobble, and over time they overlap. That means collisions. Venus, now just as heavy as Earth, could eventually smash into us. Mars might yank Earth off its orbit and send us spiraling closer to the Sun. Imagine Earth roasting into a 900-degree furnace like present-day Venus. Or worse, drifting away into the freezing dark like a rogue planet. And even the solar system's beauty would fade. Saturn's rings? Gone. Neptune's blue storms? Vanished. Moons scattered, lost to space. The elegant, varied architecture of the solar system would collapse into a dangerous, messy cluster of Earth-sized wannabes. Instead of variety, we'd get chaos. Here's the ironic twist. Making everything equal actually destroys everything. It's the differences, the giants, the runts, the rocky middleweights, that keep the solar system balanced and Earth safe. Jupiter being huge, Mercury being tiny, Saturn showing off with rings. All those quirks are why we're here at all. So what if every planet was the same size? We wouldn't be here asking the question. The solar system wouldn't be stable enough to host life. It's a reminder that in the universe, balance comes from diversity. Each planet's unique size and role is what makes Earth possible. And that's the real takeaway. The solar system isn't perfect in spite of its uneven planets. It's perfect because of them. So what do you think? Would you want a solar system where every planet is Earth's twin? Or are you glad Jupiter stayed the big boss and Pluto stayed the tiny underdog? Let me know your thoughts in the comments. I'd love to hear your wild what-if ideas. And hey, if you enjoyed exploring this cosmic scenario, give the video a like, share it with your friends who love space, and hit that subscribe button. We've got plenty more what-ifs to explore, and you won't want to miss them. Because in this universe, the questions are endless, and the answers are always surprising.